we are talking about domain, range, and function notation. So, yesterday we talked about the basics of function, and we decided whether, if you looked at a table of values, or if you looked at a graph, or if you looked at a mapping, was it a function? Yes or no? And that was easy because you just looked to see, are all of the x's different? And that was your deciding factor. Yes, they are. No, they're not. So these words that I'm giving you today are also part of functions. Domain is a word that, all three of them, domain and range, they're both words that we use a lot when we talk about functions. And then function notation is a way of doing math problems, but it has this special f of x thing, which I'll tell you about. So, first of all, we need to talk about what these words domain and range are. So remember yesterday how I told you that you had your x, which was your input, and your y was your output, right? So I have two new words to introduce to you today, and they deal exactly with this. X, input, is also the same as the domain. And let's put that in the justification. X, input, domain. So what is the definition of that word, though? The definition of the domain, when I'm talking about the domain, I'm talking about the x-axis. So if I had, I better do it on the screen, huh? So if I had a graph, then my domain would be anything on the x-axis. So let me make it separate. Okay? So this is domain. The x values. Numbers that would be, in a parentheses, and the first number in the parentheses is an x. That's called the domain. It's just another way of saying it's the x. It's the input. And then the range, I'll do in red, is my y, is my output. And I'm going to make it a red line going up and down. The y values. The definition for range is the y values. Okay. Cool. So instead of saying x, what's the x? I might say, what's the domain? And it's in your brain is, what's the first number? What's the x? What's the input? Also, the range. If I say, what's the range? That would be what's the second number in the parentheses, or what's the output? What's the y values? All right, so keep that handy. Refer back to them. Consider a vending machine where inserting 25 cents dispenses 1 pencil, inserting 50 cents dispenses 2 pencils, and so forth up to and including all 10 pencils in the vending machine. Okay. This is like real. When I was in elementary school, I was excited to get a quarter to put in the pencil machine because the pencils like smelled or they were glitter, and I was 8 years old and I was just super excited. So this pencil machine, did you guys ever buy pencils from a pencil machine? Yeah? No. See? Wasn't it wonderful? So what we're doing is we are going to put in money into the machine. Into the machine, and out comes a pencil, right? So I'm going to just do this on the side real quick, and I'm going to say that money gets put in and a pencil comes out. Isn't that how it works? So any money that I'm going to put in is going to be my input. It's going to be my X value. It's going to be my domain. So up to and including 10 pencils for the vending machine. So I'm going to say that the domain is going to be the money. So that would be like the 25 cents. What's going to be my range then? How many pencils come out? If you put in, how many, whoa, I don't know what that is. Whoa. Many pencils. The output. So if I put in 25 cents, what is my output? If I put in 25 cents, what's my output? What's my range? If I put in $1.75, what is my range? If my domain is $1.75, what is my 7 pencils? And so on and so forth, okay? That's just an example, all right? All right, so now we're going to actually do this mathematically with your job is to just list what's the domain. So on my table of values, what's my numbers that are the domain? 7, 3, 5. Do not change the order that you see them in. Just, you might think, oh, should I put it in alphabetical order? No, you don't need to. Just write it as you see it. Great. For number A, what's my range? 6. -2 and 1. This is as hard as domain and range is, which means that this is the simplest thing ever. If I have a mapping diagram, what's my domain?
2, 6, 8.
What's my range? Think about it before you say it. Because 4, 4. Yep. Good. All right, the only way that you're going to be successful with part C is if you identify what the ordered pairs are first. So that means that you need to write them in. So I need to do up here, is this 2, 4, 4, 2?
2, 4.
Well, look at you guys. Smartest things ever. The far right, 5, 3. In the bottom, 3, 1. Okay. Now you can list the domain. What are the X's? What are the first numbers in the parentheses? 2. What are the ranges? What are the Y's? What are the outputs? No, you have to go in the right order. If I start with 2, then what are you going to put first for range?
1.
If I then put 3, what are you going to put next?
1.
If I then put 5?
3.
Thank you. It's always good to just keep things in the right, proper format. And D is super simple. Do it. Yeah? Okay. Moving on. Each of the functions that you have seen has a finite number of ordered pairs. Finite number means that I only gave you like 3 or 4 numbers, or 3 or 4 ordered pairs. What would happen if what the question is asking is that describe a difficulty that may exist if I want you to write down the domain and range of this infinite number. Infinite means like hundreds and thousands and, okay. So what's the difficulty with me saying, can you guys write down on a T-chart, table of values, an infinite number of domains and ranges? Like, what would be the problem with that?
It could be anything.
You'd be doing it forever. There's too many numbers. So the difficulty is that we need just a specific amount. Like 3 or 4 is plenty. Because otherwise you're going to be sitting writing all day. So there are too many ordered pairs to write. And how am I going to put it in a table of value? How am I going to make a mapping for hundreds and thousands of numbers? It's just not practical. Okay, next question. Sometimes machine diagrams are used to represent functions. This is an input-output function machine, we call it. This function machine is just a fun, creative, way to do the math problem. I'm going to put in an x, I'm going to put in a number, and inside the machine, I'm going to multiply 2 times that number, and I'm going to add 5, and then out is going to come an answer. So you're basically plugging in a number, that's your input, and then do the math, boop, 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 beep, boop, boop, beep, and then out comes your answer. It's like a little function machine. So this is what we're doing. If x equals 7, so if I put 7 into the machine, what comes out? So you do 2 times 7 plus 5. Part B. Let's plug in negative 2. 2 times negative 2 plus 5. Plug it in, plug it in. Part C. Ooh, let's just do it together. 2 times a half. Let me write it first. That'd be great. 2 times half plus 5. Half of 2, 1 plus 5. Okay. So pretty easy still. Is there a limit to the numbers that I could put into this machine? No, there's no maximum. I could spend all weekend just plugging numbers in. Hundreds, thousands, 10,000s. No limit. You could plug in any number. Explain. I can use any number with this machine. I'm calling it a machine because that's what it is. So I could put any number my little heart desires, any number I want. Okay. I'm going on. Now I'm not going to draw a little machine with a conveyor belt and gears, every single math problem. So now it's just simply, here's how it looks. I want to give you the values of x, and you have to tell me what y equals. So here's a great way to do it. I need to do negative 2. I need to do 5. I need to do 2/3, and I need to do 75 cents. So my y is my output, right? That's what the answer is going to be. You are plugging in for x. 9 minus 4 times negative 2. 9 negative 4 times negative 2. Positive 8. And you're doing them for all 4 numbers. 9 minus 4 times 5. 9 minus 4 times 2/3. So I'm going to actually make this like 4/1 times 2/3, because that's way easier for fractions. But it's still 9 minus 8/3, which, by the way, 8/3 is what? Divide it and make it a mixed number. What's 9/3? 2 and? Okay. 6 and 1/3. Negative 11. 17. 75 cents. So I'm going to have to do like 4 times 75 cents. 75 cents plus 75 cents plus 75 cents plus 75 cents. Okay. So I'm going to give you money. I'm going to say, here's 75 cents. Here's 75 cents more. Here's 75 cents more. Here's 75 cents more. How much money have I given you? $3. 9 minus 4 times 3. Or, I'm sorry, 9 minus 3 equals easy. So is this pretty easy? Okay. Let's just, for part B, 1 over negative 2, 1 over 5. Okay. Now, this isn't so friendly, this 1 over 2/3. We talked about it, gosh, in August. How do I get rid of the 2/3? By?
3 over 2.
Top and bottom by 3 over 2. Because I want the 2/3, I don't want a fraction on my denominator of a fraction. That's just too crazy. Yay, the 2's cancel. The 3's cancel. The only thing I have on top is 1 times 3 halves. So your answer is just 3 halves. And then 75 cents, we don't really do that either. 1 over 0.75, it's just, I mean, we're going to leave it like that, but it's just weird. You know, it's like, So you're just plugging in. You're plugging in an X, and you do the math, and out comes a number. I'm going to go on. Are you caught up to the problems? No one's talking. You guys don't want to talk? What? When referring to the functions above, it can be confusing to distinguish among them since each of them begins with y equals. So, we're going to write something different instead of y equals. And a lot of times when we write y equals, you guys, your brain thinks, oh, I'm going to graph it. So, this function notation means the function of x. F, and then in parentheses, the x, because the x is the number that I'm going to plug numbers in for. And F means it's function notation, the function of x. So it's just a way of saying, you're going to plug in a number for x and do the math problem. And your answer is a function. And the whole math problem is a function. So, instead of y equals, you're going to see f of x. Don't let that scare you or bother you. It's just going to be written so that you know, oh, we're doing functions. Okay, the question says, evaluate f of x equals 3 minus 2x for x equals 0, x equals 1, x equals 2, x equals 3. Do you guys want to do a table of values or a mapping diagram? I heard one of each. I don't care. Which one do you want to do? Okay. This is really the best way to do it. A really large table of values. And remember, x is also called the domain, y is also called the range, and I'm going to run out of space so fast. But it's okay, I can do this in my head. 0, 1, 2, 3. 3 minus 2 times 0 is 3. 3 minus 2 times 1. I already messed up. 3 minus 2, 1. 3 minus 2 times 2, 3 minus 4. 3 minus 2 times 3, 3 minus 6. So easy. You're plugging in numbers, you're getting an answer out. Oh, I didn't even record that whole thing. Okay, x is going to stand for x. Instead of f of x, I'm going to put y. So what I did on this page is I plugged in, what would it look like if I had a table of values? What would it look like if I had an order pair? What would it look like if I had mapping? What would it look like if I had a graph? Okay, so now let's kind of look at the next page.